This video is over Lesson 5 in the Unit 8 packet. It is over graphing square root and cube root functions. So when we are graphing, I want you to know the basic shape of these graphs. To get that, we can first look at the parent functions for the square root and the cube root graph. Go ahead and take a look at the table for this on your graphing calculator. So go to y equals, type in square root of x, and then hit second graph. And it's going to give you points at 0, 0. Zoom in a little bit on this. 1, 1, 4, 2, 9, 3. There's lots of points in between there too. I only focused on the perfect squares because those are the easiest for us to plot. Okay, so every single one of these square root graphs is going to take on some kind of shape that looks like this, where it has a starting point, like this one is at 0, 0, and it goes off in one direction, gradually increasing or decreasing depending on negatives. The starting point for this one is at 0, 0. In a future example, I'll show you how to find the starting point. It is important to be able to find that point without your calculator. Notice if you scroll up to x equals -1 on your calculator, it says error. It's because you can't take the square root of a negative number and get a real answer. The next part of this is just identifying the domain and range. Remember, the domain is the set of all x's from left to right. And the range, sorry, my cursor is not working very good. The range is the set, sorry about this, guys. The set of all y values. And on this, we go down to up. So the domain in this case, notice the farthest left that this graph goes is 0, 0. So looking at that x value 0, our domain is from 0, and it keeps going to the right forever and ever, so from 0 to positive infinity. Our range, our lowest y value is also 0, and it keeps going up forever and ever. Your domain and range will not always be the same. We'll look at some examples where they're not. Okay, once again, go into y equals, clear it out, type in cube root of x. To do that, let's hit math for x. And then plot the points that it gives you. So you should see one at 0, 0, 1, 1, 8, 2, -1, -1, and -8, -2. When I am drawing the shape of this, I always start at the starting point, which in this case is 0, 0. I go out, up and out, and then I start at the starting point and I go down and out. It's one continuous graph, but that just helps you get that basic shape. So looking at the domain and range, the domain, remember, is left to right. So how far left does this go? Well, it keeps going forever and ever to negative infinity. And how far right does it go? Well, it keeps going forever and ever to positive infinity. And the same with the range. It keeps going down forever and ever, and it keeps going up forever and ever. Both of the previous graphs had starting points at 0, 0. Notice these other numbers that we see on these equations on the next page, page 13. These have different numbers in them. And so in order to find your starting point, you're going to look inside the radical, change the sign, look outside, keep the sign. That should look familiar. So this starting point would be -6, 2. So put a point there. Then you can type this into your calculator. Now when you do that, you're going to do square root of x plus 6. You have to hit the right arrow button on your calculator to get out from underneath the radical. And then do your plus 2. Then you can go ahead and go to your table, and you should get points at -5, 3, -2, 4, and 3, 5. So here's our starting point. We start and we go up. It does not, won't see a tail on this left side, like it stops at this point, -6, 2. Does not go past that. So our square root functions, we have a restricted domain and range. Our domain, the farthest left that this thing goes is -6, but it keeps going to the right forever and ever. Farthest down it goes is 2, but it keeps going up forever and ever. We use those brackets because there is a point at -6, 2. And that's it on these. Okay, let's take a look at this cube root function. For those interruptions, guys. Okay, so we are going to find the starting point. So we look inside, change the sign, outside, keep the sign. Puts us at negative 5, 2. And then plot more points. So we see one at negative 4, 3, one at 3, 4, and negative 6, 1. So start at that starting point, go up and out, and start at that starting point and go down and out. And this is what your graph should look like. That's what I'm expecting. Your domain keeps going forever and ever in both directions, and your range keeps going forever and ever in both directions, as you will see on all cube root functions.